In this video, we are going to discuss a category of functions called direct variation functions, how to write and solve equations involving direct variation, and how to identify examples of direct variation from data given in tables. By now, you've seen plenty of examples of functions. Some form flat lines, while others form slanted or even curvy lines. Some pass through the origin, while others do not. The topic of this video is direct variation functions, which are graphically represented as straight lines that pass through the origin. Algebraically, direct variation functions can be written in the form y equals kx, where k determines the slope of the line. K can be any number, whether positive or negative, whole or otherwise. Let's look at an example of direct variation. Y equals 3x. This function satisfies the conditions of direct variation because we can easily see that it is written in the form y equals kx. In this case, k equals 3. Since this function is an example of direct variation and follows the form y equals kx, where x is raised only to the first power, we are guaranteed that the function is a straight line. Additionally, whenever x equals 0, y equals k times 0 equals 0. So the line also passes through the origin. Sure enough, this can be seen in the graph of y equals 3x. Direct variation functions like these can be helpful in solving real-life problems, as we'll see in the next example. Air Force One can fly at the astonishing speed of 600 miles per hour. If the number of air miles traveled by the president is represented by y, and varies directly to the number of hours flown, represented by x, how far would Air Force One travel after 4 hours? To answer this question, we need to realize that the phrase varies directly is used in the problem statement. This means that we will use the direct variation formula, y equals kx. We are told that y is the number of miles traveled and that x is the number of hours flown. We are also told that the plane travels at about 600 miles per hour. This is our k. Putting this k into the direct variation formula, we have y equals 600x. The amount of time we are concerned with is 4 hours. So let's plug in x equals 4. Simplifying, we can see that y is equal to 2,400 miles. That is, after 4 hours, Air Force One could have traveled an astounding 2,400 miles. That's the distance from New York to California. When it comes to direct variation problems, you may sometimes receive information in other forms. Let's now discuss another type of direct variation problem, where you are given a table of information. To make it clear what kind of information such tables can hold, let's jump into an example. Vivian lives on a small hen farm and each morning she collects eggs to sell at the market. On Monday, she gathered and sold 2 dozen eggs for $4. On Tuesday, she gathered and sold 3 dozen eggs for $6. Finally, on Wednesday, she gathered and sold 2 dozen eggs for $4. We can arrange this information in a table where one column shows the dozens of eggs sold and the other shows the amount received. Or, if we wanted to present this information in a more clearly mathematical way, we could write the table with the first column called x and the second called y. Now that we have arranged the information in this way, it's time to ask, is this an example of direct variation? Before we can answer that question, though, we need an extra tool. So far, we have been using the form y equals kx to determine whether or not a function is an example of direct variation. But since we don't have y written as a function this time, we need to do a slick trick to change the y equals kx into something we can use. Notice that from the equation y equals kx, we can divide both sides by x to get k by itself. Now we have that y over x is equal to k. This is equivalent to the expression y equals kx, but we can use it to help us in problems involving tables. The key to the problem now is solving for k from each of the 3 days that Vivian gathered and sold eggs, and then checking whether the values for k are all the same across all days. If all values of k are the same, then this is an example of direct variation. Since Vivian sold 2 dozen eggs for $4 on Monday, the k for Monday is equal to y over x, which equals 4 over 2, or 2. For Tuesday, she sold 3 dozen eggs for $6. So the k for Tuesday is y over x, which is equal to 6 over 3, or 2. Finally, on Wednesday, she sold 2 dozen eggs for $4. So the k for Wednesday is y over x is equal to 4 over 2, which is also equal to 2. The k for each day is equal to 2. And since they are all the same, this is indeed an example of direct variation. In fact, now that we know that k equals 2, We also know that we can write a function describing egg prices per dozen in the form y equals kx as y equals 2x. Direct variation has many different applications. Let's run through one more example to cover the last type of problem you'll encounter. Paul has a drippy kitchen faucet, so he leaves a cup underneath it and waters his plants each time it fills up so that no water is wasted. The cup fills up once every 2 hours. Based on this information, write a direct variation equation and then use it to determine how many times the cup fills after 7 hours. We need to apply the formula y equals kx to this scenario. Here's what we have to work with: number of hours passed, times the cup fills up, and the rate at which the cup fills. Remember in the Air Force One example, we said that the speed of the plane was k. In other words, the rate of the plane's travel was k. When writing direct variation equations, we will always assign k to be the rate we are given in the problem. That means that for this problem, k will represent the rate at which the cup fills up, once every 2 hours. We will write this as k equals 1/2, because the cup is halfway full after 1 hour. Now we must determine what x represents and what y represents. To do this, let's consider the units of k. K can be described with the units cups per hour, because the cup fills 1 time after 2 hours. So k is equal to 1 cup per 2 hours. Now, remember from the previous example that k is also equal to y over x in direct variation problems. This tells us that the numerator of k will have the same units as y, and the denominator of k will have the same units as x. Our direct variation equation is then y equals 1/2 x, where y is the number of cups and x is the number of hours passed. Now, we are interested in finding out how many times the cup will fill up after 7 hours pass, so we're going to set hours, x, equal to 7. Solving for y, the number of cups, we have y equals 3.5 cups. And we're done. In this video, we've learned 2 formulas to remember for direct variation. One is y equals kx, and the other is k equals y over x. We have also encountered multiple word problems and learned some important phrases to look for, including varies directly and rate, or the word per. For problems involving writing direct variation equations, set k to be the rate, and then notice which units should correspond with x and with y. With a little practice, you'll have direct variation mastered in no time. Thanks for watching and happy studying.